Hey everybody! I wanted to spend a little bit of time going over the over question 14.25 out of Brown-LeMay Burston. So let's get started here. I've copied this question right over into my notebook, and we can get started. So let's spend a little time just going over this. Okay. So in order to do this, I'm going to write the reaction out. And I get it. I'm not including states, but I have a little bit of space, or I'm trying to save a little bit of space. I would encourage you anytime you're writing out the chemical reaction to include states if you're given them. So notice they're given here. Gas, gas, gas. Everything's gas. In order to solve this problem, we need to know what the rate expression is, or the related rate expression is, for each rate in the reaction. And so it's asking what the rate of consumption of oxygen is and what the rate of formation of water vapor is. So because it gives you consumption and formation, we don't have to include the sign. Mathematically, we should know that if it's a reactant, the rate is negative because the reactants are disappearing. If it's a product, we know that mathematically that the rate is positive because the products are being formed. So that's why you don't see a sign here. Okay, so we're going to have to make sure that we include that when we're doing our math here. Okay, so in order to do this, I think it's important to write out a related rate expression here. So the related rate expression is going to be negative 1/2, and the negative comes from the fact that it's a reactant, and 1/2 comes from the coefficient. So the coefficient here is right there. Okay, and that's going to be the change in concentration of H2 over the change in time. Okay, and that's going to equal negative the change in concentration of O2 over the change in time. And that's going to equal the positive 1/2 the change in concentration of H2O over the change in time. Okay. Now, this looks intimidating. It looks like I really know what I'm talking about, and I've taken years and years of math to do this. But keep in mind that change in concentration over change in time is just another way of saying rate. So to simplify this, to make this math a little bit easier, what I'm going to do is I'm just going to say negative 1/2 times the rate of H2 equals negative the rate of O2, which equals positive 1/2 the rate of H2O. Okay, so this is the same as that. Rate of H2 is the same as saying the change in concentration over the change in time, and that's what the whole idea of rate at the beginning of this chapter is. Okay, so knowing that, we can literally just plug and chug into any part of this to try to figure it out. So the first question, or the first part of this, asks what is the rate of O2. Okay, well, we can, in order to do that, we literally can just take this half of the equation and use it down here. Okay, so the equation that half is going to be negative 1/2 times the rate of H2 equals negative rate of O2. And keep in mind that the rate of H2 equals negative 0.48 moles per second. Okay. Once we get that, now it's a pretty straightforward plug and chug. Here we have rate of H2, here's rate of H2, so it's going to be negative 1/2 times negative 0.48 equals negative rate of O2. Well, we can get rid of negative signs here. Okay, and when we do that, we solve this, we get, well, I guess the way that I wrote it was stupid, but we'll go with it. We get 0.24 equals negative rate of O2, and then divide by the negative. You get negative 0.24 moles per second equals the rate of O2, right? Okay, and now we can do the same thing for H2O, but when we do that, we're going to use this half and this half of the equation, okay? We're going to need that part, okay? And this is going to be even more straightforward in terms of doing the math, okay? So what we know is that negative 1/2 the rate of H2 equals positive 1/2 the rate of H2O. Well, again, we know that the rate of H2 is equal to negative 0.48 moles per second. And again, the negative isn't given to us in the problem as part of the number. The negative is implied because it's a reactant. Okay, reactants, the rate of a reactant is always negative. Okay, so here we go. We're going to go negative 1/2 times negative 0.48 equals 1/2 times the rate of H2O. Well, the 1/2s cancel. These negatives cancel. And so you get that if I can extend my page here, you get that the rate of H2O is equal to 0.48 moles per second. Sorry for the unit thing, okay? So that is how we use a given rate to determine the rate of everything else in the equation. We have to use the rate expression. Okay, so now the second part of this is asking what the rate change of the total pressure is. Okay, and so that's a little bit different, but it's not really a little bit different. So I'm going to come over here, and I'm going to make sure I transfer my equation correctly. Okay, so I have my equation and my rate. And again, I didn't write down the sign because I wanted to point out and reemphasize that this is negative because because this is a reactant, and even though it doesn't say in the problem, the rate of decomposition or the rate of using up NO is 56 torr per minute, but the direction of that rate, the direction of the concentration or the pressure in this case, is downward. So that's why we put the negative there. Okay, but now it says what is the overall? The question actually says what is the rate of change of the total pressure of the vessel? Well, we need to find the rate of change of each of the individual parts, and then we just kind of add them up, and then that's what the rate of change is. Okay, so again, it's another related rates problem. So I'm going to write the rate expression out. Okay, so it's negative 1/2 RNO equals negative rate of Cl2, which equals positive 1/2 of NOCl. Okay, so to find the rate of Cl2, we're going to just, again, almost exactly like we did before. Okay, we're going to just use this half of this part of the equation. Okay, so we get negative 1/2 times the rate of NO equals negative rate of the chlorine. The rate of NO is negative 56, so negative 1/2 times the negative times negative 56. I'll do here. I'll keep this torr per minute equals negative rate of Cl2. So again, the negatives cancel, and then we do half. So half of 56 is 28, right? So we get 28, and it's negative 28 torr per minute equals the rate of Cl2. Okay, so that's one rate. And then we have to do the same thing for the rate of NOCl. Okay, and it's like a broken record. I keep doing the same thing over and over again, but I'm doing it to kind of show you the process that you would do, because this rate that you're given here could be any number. Okay, so all you have to do is find the related rate expression. Once you have that, then you can find the rate of any of the reactants or products. Okay, so we come down here and we do the same thing for the NOCl. We know that negative 1/2 the rate of NO equals 1/2 the rate of NOCl. Okay, so once we have that, then we know that negative 1/2 and the rate of NO is negative 56. Okay, equals 1/2 the rate of NOCl. Okay, the halves cancel. This becomes positive. Negative times negative is a positive. So that means the rate of NOCl is equal to positive 56 torr per minute. And that's equals the rate of NOCl. Okay, so 56 torr per minute. Okay, but that's not the problem. This just sets up the problem. We want to know what the overall change is. Well, let's look at the reaction. So now, this is the reaction, and so this is negative 56 torr per minute. And again, I apologize, my handwriting when I'm writing on the tablet is a little rough. This is negative 28 torr per minute. And this is positive 56 torr per minute. Okay? So the overall question is, what's the total pressure doing? Well, total pressure is really just the pressure of this, and the pressure of this, and the pressure of this, all added together. And so this is where the signs come into play. Well, this is going down by 56 torr per minute, but this is going up by 56 torr per minute. So these two things cancel each other out. So the overall pressure is going down by 28 torr per minute. Or, if you prefer, you can do this mathematically instead of kind of analytically. And so that's going to be that the total pressure is going to equal the pressure of the NO plus the pressure of the Cl2 plus the pressure of the NOCl. That's law of partial pressures. So that's going to equal negative 56 plus a negative 28 plus 56. When you do that, the total pressure change is going to be 56. I'm looking at this. It's going to be negative 28, and then again it's torr per minute. Okay, so that's question 14.25 in Brown-Lemay-Burston. And if you have any questions, feel free to reach out. Have a great day.